Yeah, good morning, everyone.
Good morning, ma'am.
Yeah, is my screen visible?
Yes, ma'am.
Yes, ma'am.
Yeah, yeah, okay. We'll wait for 5 minutes for everyone to join, then we'll start the session. So, yeah, we'll start the session. So, today we'll be solving a few problems from week 5 and week 6. And we will also see the derivation that we did, skipped the last class. So, that derivation also will be seen today. Yeah. So if you guys have any doubt with any practice assignments in and practice assignment and graded assignment in week 5 or practice assignment in week 6, if you have any doubt with any questions, then post your doubts in the comment section. We will discuss that also today. So yeah, so today the first question is for the circuit shown below. We are supposed to find the voltage across the 6 ohms, right? Yeah, I will give you around 3 to 5 minutes to solve. Then we will solve it together. I'm audible, right?
Yes, ma'am.
Okay.
Yes, ma'am.
So yeah, how to solve this problem?
Ma'am, in this circuit, the 8 ohm is it gets short-circuited, and the 1 ohm is of no use as it's open circuited. So our circuit will have only 2 ohm and 3 ohm and 6 ohm. And then we'll
Yes, right.
simplify the 3 ohm 6 ohm as we'll get equivalent resistance as 2 ohm, and then 2 ohm and 2 ohm are in series, we'll get R equivalent as 4 ohm. And then by Ohm's law we'll find the current that will be equals to 1 ampere. Then either of the we can find the by current division rule the current through the 3 ohm or the 6 ohm, and then by using Ohm's law we can find the V naught. the potential
Yes.
across the 3 ohm or the 6 ohm, which will be equal. That is 2.
Yes. Yes. What Amit said is right. Yeah, we'll solve it. So basically, since there is a resistor here and it is short circuited, current will not be flowing through this circuit and current will flow here. And here it is open circuited. So this 1 ohm is also of no use. So my current will be flowing here through this 3 ohm, through the 6 ohm, and then combine and flow through this 2 ohm. And I'm supposed to find the voltage across this point and this point, which is same as this V naught, right? So I'll draw the simplified circuit. 4 volt, 3 ohm, 6 ohm, and 2 ohm, right? And here the R equivalent is 1 by 3 plus 1 by 6, the whole inverse, which is nothing but 2 ohms. So again my circuit will get simplified as 2 ohm, 2 ohm. And I am supposed to find the voltage across this point. So my V naught will be 2 by 2 plus 2 is 4 into 4. It's 2 volts. So first we found the path through which the current flows. Then we found the R equivalent. Then we applied voltage division rule. Yes. So shall we go to the next question?
Excuse me, ma'am.
Yes.
Ma'am, can you please explain like the last step on the voltage division rule? How do you apply that?
Yeah. So I am going to find the voltage across this 2 ohm resistor. So my V output will be equal to uh, this resistor R1. I'll take it as R2. So R1 by R1 plus R2 into the total voltage, right? Here my R1 is 2, R1 plus R2 is 4, and my total voltage is here, is 4 volts. 4. And this will get cancelled, so my voltage is 2 volts. Is it clear now?
Yes, ma'am.
Okay. Shall we move to the
Oh,
next
Professor,
question?
sorry, Professor.
Yes.
Concerning this question, can I know, because I was late, sorry, but can I know what's the lower graph is about?
Lower
I
graph?
mean, this yes, the lower graph you drew. I mean this one on the
Yeah.
downside.
Okay.
Where is this voltage source? Is this voltage source VO or the 4 voltage 4
Yeah, see. This one, this is a 4 volt, which I have drawn here. And this is the voltage we have to find, V naught, which I had drawn here, right? So actually, if you see in the circuit, the current will not be flowing through this 8 ohm since it has been short circuited at this point. And in the same way, the current will not be flowing through 1 ohm since it is open circuited, right? So first I have drawn
okay,
the
I got
current path. Yeah. So the voltage across this 6 ohms is same as the voltage V0, right?
okay, I got it. So that's why I didn't understand why VO with open circuits means. So
Okay.
what does VO means? Sorry. And Professor,
Yes.
another question. I passed the qualifying exam, but my score of ASTC is unacceptably low. So I was wondering, is that, I mean, is that possible? I mean, is that possible to see, like to see the question paper I did or something? I just don't understand why I made so many mistakes.
You want to see the question paper?
No, I mean I cannot see the question paper again. I just no
Actually,
doesn't matter. It doesn't matter. I just if I next time next quiz if I like have like a higher score, so it would be my final score would be better, right?
yeah,
So
yes, it's fine. If your quiz one score is not much as you expected, but it's fine. As long as you try now, it's good.
okay. And I tried to register a course today. I found there's a in my portal there's a choice to uh, like I can register a lab course on of ESTC. So does that mean that I need to fly to India because I'm not in India now? So does that mean that I need to fly to India to take the lab course, or I can take it online?
There will be a offline lab session in the month of September, right? So like okay, like the situation about you, I'm not very sure, but maybe I'll confirm with others and I will let you know.
Okay. So and the registration would be the deadline would be today. So I'm not sure.
In
So I'll send an email to.
okay, yeah, you wrote an email to support team.
Yes. Thank you.
Okay, and you didn't get. Have you written or you're ready to write?
No, I haven't written yet because
Yeah,
the register tab. Okay.
yeah, please contact the support team no, for these type of questions. Maybe I will also try from my end.
It's okay. I'll write to them. Thank you.
Yeah, yeah. So yeah, we'll move to the next question. Yeah. So this is the fourth question of the graded assignment week 5, and we are going to use superposition principle to find the current I1, I2, and I3. Right? Yeah. Try solving this now. First, we'll solve for I1. So basically, here there are three voltage source: one 5 volt, 15 volt, and 25 volt. So we are going to use superposition principle. So what's the first step? What is the first step of
As to we have
superposition
to
principle?
keep we have to keep one
Energize
force as
5 volts and
energizing
de-energize 15 volts.
and
Yes.
de-energizing the other two sources.
Yes. Right. We'll energize 5 volt, and the other two volts, 15 volt and 25 volt, will de-energize it.
Ma'am, can we use the nodal method for this question?
If the question in the question, if they haven't mentioned the way to solve it, then it is fine. You can use any method you want. But since this problem is in week 5, I will solve it using superposition, because the aim of this practice assignment is for you to get used with the superposition principle. Right?
Yes, ma'am.
Okay. Into, yeah. Tell me the current I1 no in this circuit.
1 ampere.
Okay. 1 ampere. Did everyone get the same answer? Is it 1 ampere?
Now I'm getting 0.05.
Yeah, it will be 0.05, right?
Yes, ma'am.
So this 10 ohms and 10 ohms are in series. So the R equivalent here is 20 ohm. And this 8 ohm and 20 ohm are in parallel. 1 divided 8 plus 1 divided by 20. The whole inverse. So it is 5.71. So till here the R equivalent is 5.71 ohm. So the total R equivalent is 10, 15, 20, 25.71. So I1 here is the current flowing through the whole circuit. V is equal to IR, so I is equal to V by R. So it's 5 divided by 25.71. So it's around 0.19, right?
Yes, ma'am. I'm getting the same
Yeah.
0.19444.
So the next step is we will keep only the 15 volt and we'll short the other two. Volt, 8 ohms, 10 ohms, here that it is 5 ohms, then 10 ohms, 5 ohms, 10 ohms, right? So yeah, and I have to find the current that is flowing across the 5 ohm resistor. So this is the I1 that I need. Right? Yeah. Calculate and tell me what is I1 in the second case. So these two are in series, right? And these three are in series. Yeah, did anyone find the answer?
Ma'am, is it minus 0.41?
You got minus 0.41, right?
Yes, ma'am.
Okay, wait to check. So basically, the current is 0.833 and there are 220 ohm. So the current through each will be by 2. So it will be 0.416 around. And if you see,
Yes, ma'am. It's getting
yes,
0.41666666. Yes,
yes.
ma'am.
So the current is actually flowing in this direction in our case, what we found. But the sign convention is in the opposite direction, so we are putting minus. Yeah, the answer is
Minus.
right, minus 0.41 ampere. So we have found two currents. Now we'll find the third current also.
Excuse me, ma'am.
Yes.
Ma'am, actually, these three questions were discussed in the previous class.
Okay,
Exactly.
these questions are
Yes, ma'am. Ma'am, actually, they are the week 5 graded assignment questions. Uh,
okay.
the third question. And like, they were discussed by, uh, I think, Mrs. Ananya.
Okay, okay. So yeah, we'll complete this question and we'll move on to the next question.
Okay, ma'am.
But the last session it was about the quiz one discussion, right? Okay.
Ma'am, there was a session like after your session also. Only the yesterday session was cancelled.
Oh, okay, okay. So yeah, then fine. I thought like last session like these questions were asked in the comment box, so I thought I will solve this today.
Ma'am, I only asked this question.
Oh, okay.
Yes, ma'am.
Then fine. Yeah. Just tell me this I13 part, then we'll go to the derivation part. Fine, no?
Yes, yes.
Professor, sorry. My question my question is that if I use a superposition in this question, and finally I need to like sum up all these three currents, right? But
Yeah.
when I need
Yes.
to sum them, when I need to add them, they are like a different current direction. So how can I add them? Like sometimes it's positive, sometimes it's negative. So it's confusing. It's very easy to make a mistake.
See, while we are see in the second case, my answer is in negative, right? So what does this negative signifies? That
Yes.
to the given direction I1, the current which I found is in the opposite direction. So here I found it is in this direction my I1 is equal to 0.416. So in order to make the direction to be similar, here I made it as 0.41. So in the final answer, how will you do? You will write the first current which you found, which is 0.19. Then you will subtract 0.41 plus I13 you will add, which you are about to find. So that you will get the I total.
Ah. Okay.
Okay.
Hmm. Sorry, Professor. Another question. I mean,
Yes.
when I did this mock exam,
Mm.
your assistant did a very good handwritten solution, and I found that when he or she did this word solution, he or she prefers KCL to KVL or superposition. So I found
Mm.
it's very efficient to use KCL. Then I learned it and I used it in qualify exam that I did it wrong, that I made a mistake. So I'm so now I'm very confused with all these methods.
Okay. You tried solving it with KCL, but it was very confusing. That's what you told, right?
Yes.
It's okay now. So the best thing to practice different method is take the same problem, solve it using different method, and try practicing like that. It will be easier that way. So yeah, here what is I3? It's 20 ohms here, and 20 ohms and 8 ohms are in parallel. So the total equivalent is 5.71 ohm. So R equivalent is 25.71 ohm.
Ma'am, is it 0.277?
What did you get? 0.
277.
Okay, let's check. Yeah, the current is 0.277. Yes. And it is positive, right? 0.277.
Yes, ma'am.
0.19 minus 0.14 plus 0.27 is the total current, which is 0.32. Right?
Yes, ma'am.
Okay. What is the total current? It's not 0.32.
Zero point zero 0.061.
Yeah, it's 0.06. Yeah, 0.06. Yeah, we'll go to the derivation, which we skipped the last class. Fine, right?
Yes, ma'am.
Yes, ma'am.
Yeah. We will look into the RC step response. Have you guys watched that video?
Yes, ma'am.
Did you guys have any doubt in that derivation? Yeah.
Like, there is no doubt related to that, but like difficult to understand. And you were telling that there's a easy method for some steps for that differentiation.
There are no easy methods, but like
The steps are
actually see,
there's a method like which can be easy to understand. You were telling something in the last class. I don't remember it properly.
okay, yeah. So what I meant to say, there are many like in the derivation will be like we will be bringing some other equation. We will be deriving from it to bring the actual equation from our equation. Wait, I'll write exactly what it is. So there is a V input and there is a resistance R and a capacitance C, and this voltage I'm taking it as Vc of t, right? We are going to find the RC step response. Initially, we are assuming that the voltage at the capacitor at time 0 is 0. It means it's completely discharged. Yeah. So what did we do first? We will apply the KVL, right? V in of t is the potential increase will be equal to the potential drop. The potential drop is nothing but IR plus Vc of t. So this is the first equation we got by using KVL. Here we have to notice Vi of t is a function of time, Vc of t is a function of time. What else is a function of time? Here, what are the parameters that are a function of time?
The V input and the V of C.
What about I? I is also a function of time, right?
Yes, ma'am.
Yes. R and C are the constant values here. So it is better to write, to avoid confusion, I write it as I of t. Into R. So this is one equation we have derived. And we know the same current is flowing through the whole circuit, right? So the current through the capacitor, I of t is equal to C dV.
C dV upon dt.
Yes, C dVc by dt, right?
Yes, ma'am.
So how we got this equation? Q is equal to CV. So dq by dt is C dV by dt, which gives I is equal to C dVc by dt, right? Yeah.
Yes,
So we
ma'am.
have got two equations. We will apply the second one in the first equation. So V in of t is equal to R C dVc by dt plus Vc of t, right? So this is a differential equation. There is a differential term of some parameter and Vc of t plus, since V in of t is not dependent on Vc, this Vc parameter, I will take it as a constant. So there is dy by dt term, y term and a constant term. But we know that if my current equation is in this format, dy by dx is equal to f of x. For this format, I know the answer, right? If my equation, if somehow I bring it to this format, then I will be able to apply this equation, which is y is equal to integral of f of x dx plus c. Why is it like this? Dy by dx is equal to f of x. Applying integrals on both time with respect to a dx plus c. My current equation is in this format, whereas I know if my equations, if somehow if I bring it to this format, I can apply this integral directly. So that's my goal. That's why I'm going to like little change my equation. First, what I'm going to do is I'm going to divide by RC everywhere, dVc by dt plus 1 by RC Vc of t is equal to V in of t into 1 by RC. Yeah. Then what's the next step? To further simplify it, what I'm going to do is I'm going to consider these terms 1 by RC as P of t and this term as Q of t. dVc by dt plus P of t, Vc of t, Q of t, right? Then we will multiply by e p dt everywhere. dVc by dt plus P of t, Vc of t, e integral p dt is equal to Q of t, e p dt. Then we'll stop this derivation here and we are going to find another one. The reason why I'm going to do the next step is to simplify the left hand side of my equation. So I will take two terms, which is Vc of t and e p dt. I will apply integral on both sides. I mean, I will differentiate it. I'm not applying integral, I'm differentiating. So if you see, it is in the format uv the whole differentiable is equal to uv dash plus u dash v, right? So I'm going to apply this formula here. Vc of t, I'll keep it like that. Then I will differentiate the next term e integral p dt plus e integral p dt, I'll keep it like that, into d by dt Vc of t. My Vc of t will remain the same. What is d by dt of e power ax?
It's e to the power ax into a.
Yeah. So the same thing will apply here. But here, okay. So my e term will remain same. Then I will differentiate only this one, d by dt of integral of p dt plus e integral p dt into d by dt of Vc of t. And my differential and integral term will get cancelled. So Vc of t, this p of t, e integral p dt plus e integral p dt d by dt Vc of t. So if we once we complete the derivation, we'll understand why we are doing this step. Because if we see this equation and this equation, both are same, so we will replace it. We'll replace by this term, d by dt of Vc of t e integral p dt is equal to q of t e integral p dt, right? So we have basically achieved df of x by dx is equal to f of x format, right? So from here, I mean not df of x, it's dy by dx. So y is equal to integral f of x dx plus c. So the same equation you're going to apply in this equation. Vc of t dot e integral p dt is equal to integral of q of t e integral p dt dt plus c, right? Now we are going to apply the values of p and q. 1 by rc, q of t is nothing but b in of t 1 by rc. And if my b in of t is a step input, what is a step input? What is a step input? Yeah, am I audible?
Yes, ma'am.
So yeah, what's the step input?
Like the input voltage waveform will be in a square wave.
Yeah. Is it a square wave?
It'll like attain some voltage and be constant till the end.
From in the positive side, it will be a constant. U of t 1 by RC. So we'll apply these things in the this and this one in this equation. So what I'll get is Vc of t e power integral 1 by RC dt is equal to U of t by RC integral again 1 by RC dt plus C. One by RC is constant dt. Integral and differential will get cancelled, so it becomes t by RC, which is equal to U of t is 1 in the positive side, so I will ignore it. 1 by RC, then again e power t by RC dt plus C. 1 by RC, I'll take it out. So again, it is in the format e power ax dt, right? How to integrate it? What is the formula? E power ax
It's e
1
to
by
a into 1 by.
and this one will get cancelled. Only t by RC I will have. Vc of t e power t by RC plus C. From here, this I can also take the t by RC outside. So 1 plus C e power minus t by RC. This and this will get cancelled. So Vc of t is equal to 1 plus C e power minus t by RC. Yeah. Do anyone have any doubt in this derivation?
No.
Yeah.
No, ma'am.
Here we'll apply the zero at time is equal to 0 condition, and we'll find the value for C, and the value of C is -1, right? So Vc of t, if my input voltage is given as some u of t of some values, then my formula will become 1 minus e power minus t by RC. Here, what is RC?
It's time constant.
Yes. Its unit is?
Second.
Yes. So dimensionally speaking, RC's unit is second. So what happens at time is equal to infinity?
It's is equals to Vm.
Yes. So if I draw the graph now, this I will take it as time. This is the step input I'm giving, u of t. Okay. And at time t is equal to infinity. So initially at time is equal to 0, the voltage across the what is Vc of t? It's 0. And when the time becomes infinity, it is attaining the maximum value, right? That's what we found by this derivation, right?
Yes, ma'am.
Yes. Yeah. Then we'll also find this at the time taken to reach Vm by 2. Time taken to reach Vc of t is equal to Vm by 2. Because we cannot find this infinity value, so we'll take a time to quantize it, the time that can be quantized. So we'll find this time t1. We'll name it as t1. So Vm by 2 is equal to Vm 1 minus e t1 by rc. This and this will get cancelled. What is t1 value here?
You
RC
get
of
0.693 RC.
Yes. This is one important time, and that is the time at which it's 0.693 into time constant. At that time, my capacitance voltage will be reached the half of the maximum voltage. Yeah, we will also solve some problems from week 6. Yeah, what is the power absorbed by the circuit? This element. We'll solve this question.
6.
Yeah. So the positive terminal, the current enters the positive terminal, and the voltage across is 3 volts. So it's 6 watts, right?
Yes, ma'am.
So we'll go to the next question. Yeah, what is the power absorbed here?
-3.
-3.
Because the current is entering the negative, so it is minus 1 ampere into 3 volts. What about the next one? Here again, the current is entering at the negative.
10.
Yeah. These type of questions, please take care while writing the signs. Yeah, we'll see this question, 17th question of the practice assignment. So what they are given for the following RC circuit diagram, V of t is a square wave signal with peak 0 to 100 millivolt. Assume that the square waveform has a 50% duty cycle with a voltage ranging from 0 to 100 millivolt. First, we'll find the time constant. What is the time constant here?
R into
R into C.
Two milliseconds.
Yeah, it's 2 milliseconds, right? Yeah, and the 17th question what they have asked is the maximum voltage across the capacitor Vc of t during the first cycle of the input square wave. Frequency they are given as 0.5 kilohertz. And Vc of 0 minus, that is initially the capacitance has been charged to 50 millivolt. So how will we solve this?
From the frequency, we can find the t value, like frequency is equal to 1 upon time period.
Yeah, what is it?
Uh, 2.
Yes. So what's the
Vc of 0 is equal to Vm into 1 minus e to the power of minus t by Rc. minus 2 minus 1 because minus 2 by 2.
Yeah. RC. This one is RC value. This one is T value, right?
Yes.
Here they are given us 50. Vm is 100 milli. So 1 minus C e power minus 1. Is it 1?
Yes, ma'am. Because it was 2 milliseconds upon 2. The RC
2
value was not good.
milliseconds. So what is the value of C here?
Ma'am, where is C? Like, you would find the E value, no? Or the T.
Wait, they have asked me to find Vc of T. But here Vc of naught is not 0. So first I will find the constant for this particular Vc of 0 minus.
E by 2.
Yeah, wait a minute. Yeah, it's E by 2, right?
Yes, ma'am.
So the value of E is
2.71.
yeah 1.36.
Won't it be like 3.162?
What you got?
3.162. The E is the anti-log, no?
Yes. Wait, I will solve it. 1 minus C e power minus 1.
I am getting 0.693.
Yeah, it should be around 0.6. That's what.
It will take long.
That's 3.16. The anti-log of 0.5 is 3.1.
But I'm getting 1.35. Oh, yeah, this question we will. So, what did you get for C value?
One, like because I took the anti-log of 0.5, so I got 1.36.
Yeah, I took out 1.36. Wait. So, the next step we will be finding Vc of T, right? Applying the C value. Yeah, okay. Wait, right. Actually, we are applying the 0 at time is equal to 0, right? So Vc of 0 minus is equal to Vm of 1 minus C e power minus t by Rc. For at time is equal to 0, this condition we are applying. At time is equal to 0 also we have to apply 0, right? Vm is equal to 100 milli. This is 50 milli. So 1 minus C to the power of 0 by 2 millisecond. So e to the power 0. It's e to the power minus 0, right? 50m is equal to 100m. 1 minus C e to the power 0 is nothing but 1. Yeah. Is it
Why
right?
the power of 0?
Because see, this we are applying the 0th time condition. A time is equal to 0. They are given Vc of 0 minus is equal to 50 millivolt. So this condition I am applying in this equation. So my Vc of t will become Vc of 0 because see, this is the equation, right? Vc
So,
of t
ma'am,
is equal to
that
Vm.
voltage T which is given to us, like the 2 millisecond.
Yeah, this one is not for at 0th time. This is the total time.
Oh, okay.
It will be at 2 milliseconds. This is a 50% duty cycle they are talking, no? 0. This is for this one.
Okay.
So we should have confused this with that since, yeah, it will be 0.5. So z is equal to 0.5, right?
Yes, ma'am.
Yeah. Then we have found c is equal to 0.5. Now we need to find Vc of t. At time is equal to what they have asked us, the maximum voltage they have asked, right?
Okay, ma'am.
Yes.
For finding the value of C, we have to always do a T is equals to 0, right?
Yes.
And then whatever the value which we have to get for C value and then put it in the formula, right, ma'am?
Formula. Yes. We want to find the maximum voltage across the capacitor.
So what happen if it is VC is 0?
If Vc is 0, then my it, yeah, if my Vc is 0 at initially, I will
C
apply the
becomes
condition
1.
at t is equal to 0, Vc of 0 is equal to 0. That too, that condition I will apply and find out C. That I will get minus 1.
It should be 1.
What should be 1? Yeah, can you please repeat it again?
Sorry, ma'am?
Yeah, whatever you said now, can you please repeat it again?
When T is equals to 0 and at T is equals to 0 and VC is equals to 0, C will be 1, right?
Minus 1.
Okay.
Yeah, it will be 1 now. Wait a minute. Yeah, actually, yeah, wait, I confuse that formula a little bit. It's actually 1 plus, right? See, in this derivation, finally, before here, this equation we are going to use.
Okay, ma'am. Okay, ma'am.
Yeah. So C is equal to 1 minus 0.5. It's Is it right? Are you all getting the same answer? Hello? Yeah, are you guys getting the answer?
Ma'am, I'm not able to understand like why are we taking like
Yeah, so actually I will explain it again. See, first they have given a condition at t is equal to 0, Vc of 0 is equal to 50 millivolt. So I will take the equation from the derivation and I will apply it, which is Vc of at 0 time is equal to Vm 1 plus C e power minus t by Rc, right? In that, I will apply Vc of 0 value and t as 0. Then I will solve it and I will find the value of C, which is minus 0.5, right? That minus 0.5 is the C value, which is my new C value. Again, what is the question they have asked? They asked us to find the maximum voltage across capacitor during the first cycle of the input square wave with a frequency. So if you see the input, it is a square wave with duty cycle or 50%. So if you see the input, it is not a straight one. It is changing like this. So this is the time which we found here, which is 2 milliseconds. So here it will be 1 millisecond. My capacitor graph will be like this, right? At this 1 millisecond only, my Vc of t will be maximum. So I'm taking this point. That's why here I have written as 1 millisecond. And this 2 millisecond is the RC value. This 1 millisecond is the t value. And I've applied C value. This one is the Vm value. So if I apply, I'll get 69.68. Is it clear? Or you're still confused?
ma'am, it's clear.
Okay. So how to solve the 18th question? Here they are given, assume Vc of 0 minus is equal to 0 millivolt. So my Vc of t will be Vm 1 minus e power minus t by Rc. Here Rc is 2 millisecond. My t, to find my t, they given the frequency, it is 1 kilohertz. So time is equal to 1 millisecond, right? So for this, tell me what is Vm?
Hundred.
100. 1 minus e power minus, what is t?
0.5.
Yes, it's 0.5 millisecond because this is the u of t which I have given.
Because we are considering half of the duty cycle.
Yes. This value is 1 millisecond. My maximum point is achieved at this point, which is 0.5 millisecond. Vc of t max. So yeah, tell me the answer. No? No.
I'm 22.12.
Yeah, 22.12 or 11 millivolt. Yes. Now this question is clear, right?
Yes,
Do
ma'am.
any of you have any doubts in this question?
And why you're not here, find the value of C.
Because see this derivation, this one we have already derived, right? If see here in this page, see this is the derivation which we saw. this is the equation with C value, which we applied for the first problem, because there we don't know there we don't know the C value. Whereas in the second question, I applied this equation because this we have already derived. Here we applied VC of 0 minus is equal to 0 volts, and we derived this already, no? So I directly applied this equation. Is it clear?
Yes, ma'am.
Yeah.
Ma'am, how do we find the E values, ma'am?
E value is a constant. The value of E is 2.718.
Like the power, ma'am. 0.5 and by 2, how can we find the E value then?
See, Vc of t is equal to 100 m. 1 minus e power 0, it's basically minus 1 by 4, right?
Yes, ma'am.
Yeah, see, the E is a constant value, 100 m. 1 minus 2.718 minus 0.25. This is at the power.
Okay.
Yeah. Now this value. Yeah. So the time is already about 10. So if you guys have any doubt, stay in the meet. Otherwise, you guys can leave. Do you want me to solve the next question also from 9 to 15 of the practice assignment? If anyone have any doubts in this equation, please stay. Otherwise, you can leave because I'm going to discuss this question also now. Oh, you guys are discussing your marks in the comment section. Yeah, shall we solve this problem? So if you see, yeah, is anyone trying to speak?
No, ma'am.
Yeah, what is the point? What is the voltage at this point? It's 10 volts, right?
Yes, ma'am.
At this point,
I don't know.
yes, it's 5 volts. So how to find I5? It's 10 minus 5 by 10, right? Because see, the I5 is flowing from VA to VB. So I5 is nothing but VA minus VB by R. Potential difference by resistance. 0.5 ampere, right?
Yes, ma'am.
Yes. Then here I have for 50 ohms also I have a voltage value and a resistor value. So I can find I3 also. 5 by 50, right?
Yes, ma'am. And like for finding the I4, then 5 minus 5
Yes.
150.
We will apply KCL. I4 plus I5 is equal to I3. I4 is equal to I5 minus I3. 0.5 minus 0.1, which is 0.4 ampere. Right?
Yes, ma'am.
It's actually minus 0.5 plus 0.1. So it will be like this. Yeah, minus 0.4 ampere. Then, in the same way, find I2, no? What is the value of I2?
Point 5.
Yeah. I2 is equal to 10 by 20. 0.5 ampere. So what is I1?
1 ampere.
One ampere. Yeah. So yeah. Do anyone have any doubts in this question? Yeah. So if you guys have any doubt, then stay. Otherwise, you guys can leave.